So I think let's get started. So today we're going to talk about the future vehicle. So we've been discussed the section 1 to 4. So section 5, we're going to look into about autonomous vehicle. I think everybody know about autonomous vehicle. Autonomous vehicle is now become a really important topic for all the electric vehicle development or commercial activity. It also can be used for a lot of the other issues like even the flying aircraft also have been using autonomous capability. So just like for EV point of view, there will be already international standard to look into the electric mobility autonomous vehicle. So in here, we do a standard course from level 0 to level 5. So level 0, that means nothing, just like conventional gasoline car without any capability of autonomy. And then for level 5 will be 100% autonomous. So you don't need to control them, you don't need to touch them, even though without steering wheel, without brake, and when you sit there, the dashboard have nothing. The vehicle just go. So that's called the level 5. So level 1 will have slightly more control or support from the computer, but still the driver must be there. So later on, we'll go through level 0 to level 5 so that you understand what they are. So here will be one of the picture we download from the Society of Automotive Engineers, SAE. SAE is one of the biggest organization for the automotive. They develop a lot of standard, a lot of requirement, many standards in the vehicle are all developed by them. So this picture gives you some kind of understanding what it is. For instance, you can see that the level 0 will be no automation. So that means just like our normal car, we just need to control everything by ourselves. So that means no detection, no support, no assistance. So it more look like in the 10 years ago that most of vehicles are like that. But however, for the last 10 years, vehicle has been coming out with some kind of driver assistant. So they don't actually control the vehicle. They're just helping the driver to drive the vehicle, including some more sensor, more support, or a lot of facility including. For instance, if the vehicle, say, go beyond the marking, they will give you some alert to say, now your vehicle is not cutting it at the other line. Or sometimes if the vehicle in front of you already start in the traffic light, you still look and not doing anything, they will give you an alert to say the vehicle already start in front of you, you can go, something like that. And sometimes if some pedestrian or some vehicle too near to you, they will have some alert signal to show you something happened. Yeah. So all these things have so-called driver assistant, but they're not driving the vehicle. They just support you for driving in order to reduce some accident, in order to support you have better driving. Then level 2 would be called partial automation. So vehicle has been combined with auto function. So even the acceleration, steering, but the driver must remain engaged with the driving task. So monitor the environment. So that means partial automation, the vehicle can able to control the vehicle. The computer can able to control the vehicle to, for example, like you said, the GPS, they will actually go through the GPS route to go. And then, but however, you have to monitor the system, make sure the system is good. You need to sit next to it. Sometimes you don't look at the dashboard, don't look at the windscreen, they will stop you. So that's something called level 2. So that means from progression from level 0 to 1 and 2 gradually have more functionality, more control by the computer inside the vehicle. So number 3, level 3 is called conditional automation. The driver is still highly necessary, must be there. I mean, in many cases, the driver must be there. But it's not required to monitor the environment, and the driver must be ready to take control of the vehicle at any time. So that means this more look like the so-called FSD, full self-driving in Tesla, in many other vehicles. You press the button, then you go in all the way. You don't need to touch the steering wheel, don't need to press any brake or accelerator, so the vehicle just to go. But however, they require the driver to monitor the whole scenario and able to take over when needed. In case, for instance, the AFD system, full self-driving control system, they suddenly lose the control, they don't know where to go, they would return the control back to the driver. Can be any time. And also by law, the vehicle is not responsible to anything. Car manufacturer, although they got the automation, but they are not responsible to anything. It's still the driver. So that means this kind of vehicle, the driver can take control anytime. Because of this one, then any responsibility in the vehicle still belong to the driver. You can't say, oh, the vehicle is now fully automation. It's nothing to do with me. The car crash a building, knock down a person. It's not my fault. It's the manufacturer's fault. No, because under any condition, the driver still have 100% control. You can just take over anytime within 0.1 second. You can just take over the steering wheel, take over the brake, whatever. So the driver, although you don't have to do anything, you can sit there, pretend you're going to take over, but you don't need to touch anything. Your eyes still look in the front. And then make sure you look in the front, because that camera inside the vehicle can check your view angle, make sure if you're sleeping or doing computer, checking iPhone, they will stop you. They will give you some Tesla vehicle, if you commit that crime, that's not a crime, commit this kind of regulation, several times they will stop you from using the FSD. So you have used hand driving. So that more look like level 3, right? So then nowadays, most of vehicle can go up to level 0 to level 3. Most of the electric vehicle, level 3 is one of the options they can implement now. In level 4, the vehicle is capable of performing all driving functions under certain conditions, and driver may have the option to control vehicle. So that means the automation even higher. So the level 3 already really good. Level 4 will be even high up. But of course, most of control will be there. For instance, for example, like electric train, cross-country train, the driver actually sitting there doing nothing. They sit there just in case anything happens. Even the driver doing something else, maybe going to the toilet for a short while, still nothing happened. The vehicle can still go. But the driver can take control anytime to order anything. So they are more look like level 5, sorry, level 4. And then level 5 will be full automation. That means the driver don't need to be there. Can be no driver. The vehicle have no steering wheel, no brake, no accelerator. The passengers just sit inside the vehicle. They just go without nobody have control. Only the vehicle itself will be programmed by another means. So the vehicle is capable of performing all driving functions under all conditions, any condition. The driver may have the option to control the vehicle. The driver may have, but already the vehicle has no control. Probably you can in the central computer system or in the server, in the cloud, they can still control the vehicle. But actually inside the vehicle, no control will be necessary because all these things don't need to be there. So that is to say, you can see the progression from level 0 to level 5, how it look like. So today, as I said, most of vehicle, we do the low-cost vehicle level 0 without any control. But most of gasoline vehicle should be more look like level 1. Because you can see that if you drive your own vehicle, they should have some driver assist. For example, like alarm signal, vicinity, distance signal, and also they check into lane. They can also control your speed of vehicle. You press a button in highway, you press button 70 km/h. They will always keep with that kind of the speed using their speed control system. So that is called the driver assistant, but they're not driving your vehicle. And then when you go on to level 2, 3, and 4, more control will be inserted into the vehicle. The driver gradually getting less and less duty. So more detail, you can check the link here. Then from different kind, so many links today. You go to website, you can search for from level 0 to level 5. That is the international standard for all the automation in the vehicle. So that's how we understand from layman terms how the automation look like. The thing is, from level 2, 3, 4, 5 onward, it must be electric vehicle, because only electric vehicle able to provide all this kind of automation. Gasoline vehicle will be getting quite difficult to go to level 5 or level 4. So that means gasoline vehicle can do level 0 or level 1. When you move on, the vehicle got to be full electric, because you have to control motor, control the steering, control the steering angle, control the differential speed, braking, everything. Computer control, I mean, that would much easier, convenient to use electric vehicle. So that's why all the full automation, like level 4, level 5, they must be electric. Like the cross-country train system, for example, the high-speed rail or the train system, they must be electric. You see, the train has become electric for more than 40 years, 50 years. I think most of train in many countries, they convert into electric from steam engine, from other gasoline engine into electric. Usually since 1980, most of train in the whole planet Earth are gradually move on to electric. So then that means we still drive at the time, but nowadays we don't need any driver on train, on the metro, because they're all fully automation. Anyway, so here will be more detail so to understand what that is level 0, level 1, 2, 3, 4, 5. So if you go to many websites, they will have a lot of this information. So the level 0 low drive automation, the driver take entire control. Yeah. And then for level 1, you can see the driver assistant, level 2, partial driving. Then the ADS, the automation driving system, responsible for lateral or longitudinal vehicle motion control. So that means this way, this XY coordinate, they responsible all the control. They will complete most of subtasks, but they supervised by the ADS system. And then you can see that will give you more detail about which one. So I think up to level 3, 4, 5 is the thing we are now, or many of research activity has been going on. So level 5 will be unconditional. Everything will be fully controlled. The drivers don't need to do any interfacing. So that's how we understand about different level of the driving automation. Any question up to this point? So, and then here we have been talking about level 0 to level 5. All the international definition only define this. So you can see that, let's look at more detail about level 4, 5. Level 4 means all the automation driving system can perform entire dynamic driving task, all the driving tasks, and all the specific operational designated domain without any expectation from driver. So level 4 means already really high automation. They can do everything, but they don't need driver to do anything. So that means probably the driver only press, I want to go to University today, they will set the path, they go. Yeah, whatever. Then the driver just sit there, just in case anything happen, they can still control the vehicle. In case I want to stop here to go to bathroom, then you can do that. But level 5, the driver probably don't need to intervene, maybe have no control. I think probably if you go to, say, San Francisco, there will be some taxi that's a fully automation, and then you can also drive on this taxi. But people have been complaining about this kind of taxi, no driver, the charge rate is still quite expensive, same as taxi. So that's why the user may not quite like that. They think it's a fully automation taxi, then you don't need to charge that much, because without taxi driver should be cheaper. But they say that the R&D cost is so high. So that's why they still charge it quite a lot. So you can go to San Francisco to try this kind of the fully automation taxi. So now then you know level 0 to level 5. So without looking at the next few pages, what do you think from the future development? You see this chapter, we talk about future vehicle. Level 0 to level 5 is a present vehicle, what we're doing now. All the standard, international standard, and looking into, at the moment, what we are doing. How about the future? After level 5, you know what level 5? Fully automation. The vehicle inside, you have no accelerator, no steering wheel, no braking, everything, no. You just, maybe on an iPhone, you call, you say, I want to go to then the vehicle will come to you, open the door for you, you go inside, they close the door for you, the vehicle just go to a destination, and then that's it. You have no control there. So that's for the fully level 5 system. Okay. Very similar to those automatic driverless vehicle. So now then, what do you think about next level? Would there be any next level? If you want to design, if your government, your boss asks you, I want to design a level 6 vehicle, what are you going to propose? Sheldon, what do you think?
For the next level automation drive, I think the car can self-drive in any road conditions, weather conditions. Even if it is very complex, it can, according to the road condition, to regulate the best lane. It can changes the lane by itself and save the time. Like that.
Yeah, that's a very good point. You see, from level 0 to level 5, they mainly aim for the normal condition, normal driving condition, just like our vehicle. If I have level 5 vehicle, just drive on Merced, California, this kind normal location, all the normal condition, normal traffic, they can able to adapt that. So that means some special condition for some suddenly heavy snow, heavy rain, or maybe suddenly there will be some kind of special thing happen on the road, then the level 5 system may not be intelligent enough to overcome, to adapt to that situation. So that means if your future research, I'd like to progress one more step to level 6, then we may think about we need to operate in extreme weather condition. Suddenly heavy rain, rainstorm, typhoon, whatever, Hercules, then we need to look into that. So that's the thing we need to look into, heavy snow, too foggy. You see, when it's too foggy, probably the camera inside the level 5 vehicle can't see anything. Then you need to become more intelligent to make decisions how to do, right? And then able to capability to navigate through very complex dynamic environment, such as suddenly there will be some construction. Yeah. You see, when we suddenly have some construction, maybe Google Maps is not able to respond yet. When the vehicle go to here, they find nowhere to go, then the vehicle may not be intelligent enough to do anything. Usually, this kind of vehicle, they return the control back to you, like the FSD. And because they don't know what to do, when the computer or vehicle, they don't know what to do, they return the control back to the driver. But however, for level 6, they should able to do whatever, just like level 6 more look like a human. They now become, you employ a driver, but the driver is a robot driver to drive the vehicle. Under this kind of the special environment, your driver, you employ it. When they see heavy rain, heavy vehicle, they will do their own human reaction to responsible for all this environment. If your driver, your human driver, sees road work there, GPS doesn't do anything, they'll try to navigate to other, trying this way to go through the issue. So your more look like level 6 will be have a robotic human driver to help you to navigate. So that more look like. And then not only that, they can also communicate with other environment to find out the best way to do. Single vehicle here, probably they can't do anything, but in the future, we got many autonomous vehicles nearby. Then your vehicle here cannot see what happened in front, only can see in front of you, but they don't know what happened after 100 miles, maybe 100 meters, 1 kilometer. They will communicate with other vehicle nearby. Other vehicle tell your vehicle what happened there. They will give you some guidance what to do next. So that's why they will integrate with artificial intelligence, more look like human, to help you to understand scenario, to make more decision, to improve the understanding of environment. Mainly is the environment you need to change. So that's something quite useful. And then they also have some security feature to protect anything could happen. Because normal level 5, they just drive according to the path, GPS, whatever. But in case something happen, for example, like cyber attack, they were able to react with this. Yeah, some intruder, the system able to do something about it. And the vehicles are able to provide more sustainable capability, can help you to determine which way can save more energy of driving. Today, auto vehicle, they only go from A to B. They never look into energy saving. But in the future, they may look into that. That means what kind of speed, what kind of route, when they brake the vehicle can save more energy, they will look into that. The energy saving not only for the path, maybe long-term energy saving. When they want to use the vehicle for 1 year, what kind of driving pattern, speed control vehicle can save more energy, can also extend the lifespan. So that's also more intelligent. You can see that all these features more look like the driver become a human, more intelligent. The driver will look into more feature to protect your vehicle, to assist the vehicle, to provide more nighttime, more energy saving, more solution. So that's what the level 6 look like, rather than level 5. Level 5 just doing some dummy thing without any intelligence. They are really intelligent, with only intelligence up to the driving from A to B, without any special consideration. So that's how the future level 6 shall look like. All right. And then if your boss still not happy about level 6, I want you to develop level 7 and what it should be, right? It's quite interesting. So let's see what kind of level 7 it should look like. Level 7 is vertical concept beyond the state of art in the autonomous vehicle. So in this vehicle is more than level 6, right? Must be doing something more special, more intelligent. So they can able to compete independently in driving all the scenario without any actual human intervention and oversight. So the possible additional feature could be the really wonderful environmental conception. Yeah, they do it with a lot of the additional sensor, not only camera, maybe even the LiDAR, radar, and other new technology to detect new condition and new sensing. The thing is, at the moment, our EV only limited by the sensor. For instance, like Tesla, they don't want to spend money on the LiDAR. LiDAR can detect much better because expensive. One LiDAR can cost them about maybe a few thousand. So of course, they don't invest money on LiDAR. They only use camera. Camera only probably for them only a few dollars, to a few thousand. So that's why. But some other vehicle, they may like to put at least one LiDAR there. So that means in the future, they need to put more sophisticated sensor. Not only camera, LiDAR, radar, and other technology, they may need to detect more different environment. And then they more have a more comprehensive decision making. So able to make complex decision, including the routing, obstacle, avoidance, and also critical driving condition. So they like to have more just like a human would be more intelligent human to think about more things ahead. So the feed-forward control to think about more in the future, more step to look into the autonomous operation. So that means they were able to have more communication. To do this one, you can't have your own vehicle. You can't need to communicate with many other vehicles. Not only other vehicle, maybe other pedestrian infrastructure. They may connect to internet quickly to know all the environment, connect to other website or cloud site to know other building what happened. They have a more advanced penetration of communication. They also have some redundancy system. So that means in case anything happens, they also have a redundancy system. For instance, they have more than one LiDAR, maybe quite a few camera, maybe a motor, not only 4 motor, maybe have 5 motor. In case one motor is broken, they still have another way to do. So there are more kind of the redundancy sensor, computer, and power source requirement to adapt to anything. Just like if you think you want to have more intelligence for any system, like your robot need to be highly intelligent, you need to put some redundancy system. In case any part of your robot is broken, you can still recover by itself, regeneration. We call it regeneration. So probably today, robots are not better than human because they don't have regeneration. So, but in the future, robot can have regeneration, repair by themselves. Then they should be more look like in the movie Terminator, right? Anyway, then self-diagnostic, self-repairing. That's something we look into. Right? At the moment, all the vehicles do not have capability of self-repairing and self-diagnostic. Human can. So that means this statement, more look like in the future vehicle level 7, they can able to do that. How they do that, we're not quite sure. Probably they got a few spare parts inside the vehicle. Some major component, if they need to replace, they can replace by themselves, or the vehicle can go to the shop to get the replacement or get the fixing. So that's how we think about level 7. You see, autonomous vehicle more look like a future robot. Be able to do its own regeneration, repairing, diagnostic, can look after themselves rather than a human look after them. So they're able to look after by themselves. They can survive that by themselves without human. Then that's more look like a level 7. And also they can also monitor, can able to provide more safety and well-being for the passenger. You see, our vehicle mainly is to support humans, support the passenger. So that means they can able to provide more protection, more safety protection, more functionality to support the human. So that will be provide support in case any emergency, the level 7 vehicle can do it. More importantly, will be learning. Yeah. At the moment, all the auto vehicle, the human learning first and then transfer to the vehicle. They don't have any self-learning. They do have some self-learning, just like which routing. Like for example, like GPS, if you using this route for quite some time, the GPS always point you to this route because they think this route is what you like. And then for the level 7 vehicle, they got a self-adaptive. They can learn the vehicle how to adapt to the new driving conditions, scenario, pattern, and speed, everything. So after they drive a few times, they will know which way to drive will be better. They got more intelligent, more look like human. When you drive, when you first come to Merced, you're not quite sure which road to do. After quite a few times, you know which route will be better, which route will be much easier, less traffic jam during what period of time. They work on all this and then have a self-adaptation. Or they may say, today my passenger is this one, they like my speed to be what kind of speed, they like slower speed, or all this scenario, they can record and program, they can have self-learning. So that's the thing they can do. So that you can see that autonomous vehicle have a lot of progression. So level 0 to level 5 will be standard. But level 6 and level 7 is undefined. Nobody knows what it is. So that level 6 and level 7 is what I myself to look into the future vehicle, how they should look like. But that would be really much logical. So that means you can see that level 6 are more advanced condition than level 5. Level 6 more look like level 5. It just have everything will be better, including the environmental condition better, then the control, security, everything will be more advanced, more upper level. And level 7 will have more intelligent, become more look like a human vehicle. They can look after many things, yeah, including self-repairing. That is something important. Redundancy. Just like you see when people have a 2 phone. Why is that? Redundancy. In case anything happens, they still have second phone. Right? Computer, you won't have a single computer. You have one desktop, one PC, right? redundancy, because humans are thinking about redundancy in case any key. When you go home, you usually have two keys. In case you lose a key, you still have second key in case anything happens. So that means level 7 will try to do anything more look like human to protect you, to make it adapted to the system. So that's how we call the level 7. All right. Any questions? Interesting, right? You see, robotic, autonomous vehicle, electric vehicle are really interesting topic because relate to future. Anyone can tell me, right? For the development for the technology. So for the last 20 years, we've been working on electric vehicle. That's quite certain. So today, electric vehicle already very mature. Of course, we still learn electric vehicle because we want to support the electric vehicle development for next 20 years. All the vehicle become electric. We need engineer, we need designer, we need people understand electric vehicle to maintain the society. So that's why we still teach you about electric vehicle. But for research point of view, we're still going on. But next level of research will probably go to robot. Yeah. But for last 10 years, for the next 10 years or 15 years, that will be empire for robots. So that means today you need to quickly to go into robotic system because I think in the next 10 years, probably many people start to have their own robot. Just like 25 years ago, we start to have their phone. Everybody still gradually have their phone. But today you can see that everybody have at least 1 to 2 phones. So I think robot is the same. Today, you all like to have a robot. You may start to buy a small robot, maybe robotic dog, robotic whatever to play around with it. But after 10 years, 20 years, the robot become a commodity. Right? So that means next generation will be robot research. That's what I think. How about next? What next? After 20 years, 30 years, what will be next research topic? What do you think?
Of space.
Sorry, say again?
Maybe about the space beyond the Earth, not just about peace, but the application on the space. And on there, I think the last level will be automation.
How about you, Xiaodong? What do you think?
Maybe more advanced robotics like human. I mean, the robotics can do the same thing as human, like run or do something with their own thinking.
Yeah, I think mainly about this trend. You see what we talk about, that major development is one is the so-called major development, a new kind of the system. You see, electric vehicles last 20 years. Before electric vehicle is computer, software. Like you can see that when we start to have new development computer, I think roughly the 1980s, when we had Apple 1, Apple 2, you're not in that age, but I still at that age. During that time, people start to buy their own computer, assemble their own computer. Apple 1, Apple 2 start to be there. Then later on, we have Microsoft, the Windows system. So I mean, from 1980 to year 2000, we have a lot of new development for computer. Of course, computer is still going on. But during that time, we have computer operate on everything. And then 25 years ago, we have electric vehicle start to move on. We're still going on with electric vehicle, but during that time, year 2000, we had a lot of EV, a lot of work being going on. And then for last 5 years, robot, we have the robot going on. I think it still lasts for many years. Doesn't mean that after 10 years, we have no more robot. I think robot still continue. But at the age of development, 5 years ago, we started to have robot. 25 years ago, we have electric vehicle. 45 years ago, we have the computer. Then what will be next? Then you can see that all of them has a really large system development, change the whole structure. Computer change the whole structure, right? And electric vehicle change the whole transportation system. Otherwise, you're still using gasoline. robot, of course, will change with so many different kinds of the robot nowadays. Next thing will be the bioengineering. Because you can see that the next thing we like to do will be, of course, we want to extend our lifetime. We want to extend our medical or our how to fix all the disease. Then in this case, we need to have a lot of engineering research in biomedical engineering. For example, like not only the genetic engineering, but anything related to that, how you integrate the robot with human, how to extend lifetime, electronic organ, how to change your genetic DNA, whatever. So marvel about this kind of the area. So that means if your kid, today you need to ask them start to understand robot, and then also start to look at about biomedical engineering. I think that's the trend. That will be change. What I'm talking about, not a minor change. Not all. I try to improve the building more environmental friendly, more solar power, wind power. That already done. That's only gradual improvement, continuous development. But next big development must be this kind of the robot bioengineering. But anyway, so all this autonomous vehicle also doing something like that. Level 7 start to have a more intelligent, more look like human vehicle. That's what we look into. And then section 6, we like to look into about connected vehicle. Connected vehicle, that means a vehicle being connected to each other, so that a vehicle is not alone. They will therefore communicate with other systems, including other vehicle, other building, other infrastructure. So for instance, V2G is something simple we have been looking into, right? Vehicle to grid, the battery of the vehicle connect to the power grid. So in case anything happen, the battery can support the power grid, support electricity to the power grid. That's a basic thing. But connected vehicle, we like a vehicle being connected to other vehicle, like V2V. V2V is not connecting the battery only. They like to connect with the communication. Just like what I mentioned before, level 7 vehicle, the vehicle must be connected. So you know all the environment nearby. Your vehicle may not understand what's happening, only can understand what happened within 100 meters when the camera neither able to reach. But beyond this one, we need the V2V, vehicle to vehicle, to understand all the nearby environment. So they can able to provide the sharing of information, location, speed, and direction of travel. So all these things is important. We can reduce the accident. For instance, you have two vehicles are going. Then if the front vehicle press the brake, you can only see they press the brake. You don't know how hard they press the brake. So that means if now this information can deliver to your vehicle to say, I now only press the brake slightly, only want to reduce the speed from 50 to 40, then you know it's not hard brake. But if the brake is, they want to stop the vehicle within, say, 5 meters, then that information need to deliver the vehicle behind you so that you can prepare to brake. So maybe steering as well, changing the lane, all the communication if there, then the whole city will be much safer. The traffic control will be much, much safer. Not only vehicle to vehicle, the vehicle to infrastructure, like the vehicle should communicate with other building, maybe other traffic light or tunnel or maybe traffic, maybe bus stop. Many of scenario, a vehicle will be so-called the last mile vehicle. They help you to connect to the train, boat, or airport. So that means this communication will be important. So you can know how the vehicle can adapt more in better manner with all the other public transport. So in this case, the vehicle need to communicate with the infrastructure, maybe can communicate with the timetable for the train, for the coach, for the departure or arrival in the airport. Then in this case, they can able to make control, not really make control, can communicate. Of course, in the future, things could happen. I mean, traffic light control, road control, vehicle control can have something coordinate. So that's what can happen, what we want the connected vehicle to be. So they can also provide you with the driver assistant. So today we do a driver assistant. But connected vehicle are able to help you with more facility, like the sensor, camera. And then they also able to provide you more protection for all the other environment, because the vehicle can be connected to other vehicle anyway. So the protection of the road structure, traffic, the driver, the planning can be made much easier. And then they can also make a lot of personalization, entertainment in your vehicle. Not only music, movie, you may able to share the information. Today, your phone, you can share your information to the vehicle, so your vehicle can play the music inside your phone. But in the tomorrow, they can also play the music for other vehicle. So this a lot of things could have happen. So including many personalization, entertainment among the connected vehicle. So connected vehicle haven't been defined very properly. Mainly mean I want to connect the vehicle to other infrastructure, other system, so the information, energy, data can be exchanged. So that's how we think about the connected vehicle look like. So of course, connected vehicle is heavily supporting the autonomous driving. So once we go for autonomous driving, the vehicle need to understand the whole environment nearby so that the driving can be more successful. Today, our autonomous vehicle only drive it by ourselves. You only use our own camera, using our LiDAR to detect the road surface. Maybe you also using GPS. GPS is only one thing we connect to the outside world. But I think for connected vehicle, we not only depend on GPS, we also depend on the connection to other vehicle. Yeah, so that's how you're able to make the autonomous driving more successful. In this case, you can avoid any complex environment, can avoid accident. So another important connected vehicle will be energy saving. Today, most of vehicles does not care too much about the energy. They only care about more intelligent control, maybe self-learning, this kind of the pattern, but they never think about the energy saving. So in this case, if you are connected vehicle, they may optimize their performance in terms of energy to different traffic conditions. For instance, they know this traffic has problem, your vehicle will go to another location to avoid the traffic. That's basic thing. Even GPS can also do that, but GPS more orientated to the routing. But in here, we can more orientated to the energy, weather, and also other factors to reduce the fuel consumption. So that's the thing they try to do for connected vehicle. So connected vehicle is really big topic. So not only this one, can also include many other things like the charging system. Sometimes connected vehicle can connect up. This vehicle can release energy to other vehicle. The key feature, you can see that provide the safety, performance, efficiency, and convenience. Can able to integrate the vehicle mainly to integrate with other systems. So that's how we call it connected. So in the future, many vehicles will be connected. At least all the, say, major brands like the BYD, their vehicle are connected. Tesla, their vehicle are connected. They do have some feature. So later on, if all the vehicles are using Tesla, they connect to each other, they can have much better control for the city planning, traffic control, less traffic jam, less accident. Because the vehicle know other vehicle, what they're doing. So it's impossible for two vehicles have collision. Yeah. And then the vehicle can know all the traffic light. So impossible, they will go for a red light or go for an amber light, they know that will pedestrian. So that's why I make the system more safe. So that's what we're trying to do for connected vehicles to make the environment safer. So all the vehicles should not stand alone, they're connected. So of course, to do connection like that, they need a lot of facility. For example, like 5G connectivity. At the moment, we are using so-called 4G, 5G. So we need a really good 5G network to have a much high speed of data transfer to do that. So that means without good data transfer or latency, then we can't do really good performance for the connected vehicle. AI must be programmed there because you're not only including simple program, we're also including how to program them so that they can self-learning, self-adaptation. So that's the thing, we need the AI to support them. and AR, augmented reality. So that means we should provide a driver with a lot of new information. So later on, we discuss more about AR, because they are now getting important now. The driver itself, we are not talking about full automation. The driver itself or the user itself, they like to have more information. Rather than just on the dashboard, on the screen have the information, they like to have more reality information. So it's called the AR. So later on, we talk about it more detail. Then you can also see that another issue will be the blockchain. So the blockchain technology has been there for many times. Yeah, the mainly is to use the security, transparency to share the data related to the connected vehicle. So that means the connected vehicle today is not only share the traffic condition, environmental condition, also share the data related to the driver behavior and maintenance history and ownership. So that to say, your vehicle, they will store your driver information. Today, all the vehicles, they do have your driver information. Because for driver A sit on there, they will automatically adjust the seat, adjust the mirror, so that you don't need to all the different driver, like your car being used by your wife, by your girlfriend, or by your family member. So each one have their code. One sit there, they know you are, then they will adjust the mirror, seat, whatever. So that's something has been already done. But more than that, they like to adapt to the driver behavior. Some driver, they usually only drive for maximum 70 miles per hour, but some driver may go only 60, some driver maybe 80. So they will program all this kind of the behavior. So help you with the connected vehicle. So, and also quantum computing. Quantum computing has been looking into for quite some time. I think probably in the near future, we like to use more computational power and then more data connection. In this case, the quantum computing could be something we could use in the future to assist us with connected vehicle. You see, a single vehicle have a lot of information already. But in the future, when we have a whole city of 1 million vehicles, they're all connected, then the lab was quite complicated, so many information. So which information will be needed or not needed, how to process information, which one will be important, when to process them. Today, the computational power may not be enough. So we need to have some better thing, like the quantum computing. So that's the thing we are now looking into. Haptic feedback. Haptic feedback technology is provide driver with the haptical feedback and around them. So like, for instance, the feedback may including other vehicle, other hazard on the road. So this kind of haptic feedback technology now being used in the connected vehicle, make sure that we have additional information. The information not only between the vehicle, but also the driver vehicle will provide all the surrounding information to the connected vehicle. Next thing will be the brain computer interface, called the brain wave, like in this picture. Then today we all control vehicle by automation or by hand or by a leg, right? But of course, in the future, we like to use brain wave to control that. This is not novel, not movie, but real thing already happened. I do see a lot of research going on to use brain wave to control. Yeah, for example, like the brain wave control a wheelchair. I myself have done that. The brain wave can, without any control, the brain wave control the motor to go forward, backward, and steering. That simple task has been done. So brain wave, but of course we need to connect many of the sensors on the brain. The brain wave is really, really small power. So we need a really good sensor, detect them, analyze them, convert them into suitable signal. We need to train them. Different persons have different kind of brain wave pattern. So there's a lot of research have been going on. So that means connected vehicle able to do this. So next section, we are looking into sustainable material. So we've been talking about a lot of the future vehicle feature, right? We previously talked about the autonomous vehicle and also connected vehicle. All these are some future feature, future capability for vehicle that mainly highly related to the control. Next thing we need to look into about the material, right? You see, when we develop a vehicle, in the past, a vehicle only metal, steel, and iron. recycling will be quite straightforward because we still need the iron, the steel from the vehicle. And then, but today when we develop vehicle, we need to look into many other things. For example, like what kind of new material we can go to a vehicle that can be so-called sustainable. We like all the material inside the vehicle can be sustainable, recyclable. For instance, the battery. Yeah. The battery, the electrolyte, the separator, the mini packaging of the battery. We like to make it more renewable or recyclable. So in the future, we may need to think about, can we use bio-based material to be the vehicle component? Usually bio-based materials, they are recyclable because they mainly are kind of the landfillable. They can decompose much quicker than other material, than plastic. So that means the biodegradable material, we can make them for interior, maybe some important material. But of course, today we tend to use them for battery, but we are a bit hesitating because for instance, on the battery, we need to highly secure. But if you use the bio-based material for the separator, then the separator may not able to separate the anode and cathode properly. And EV, we've been working on not only so-called aluminum vehicle. Today, we gradually move on from steel vehicle, steel body into aluminum, so that it's much lighter. At the moment, you can see that many of the vehicle EV, the weight will be something look like 2 tons, 3 tons, or 4 tons. Mainly about the vehicle is quite heavy, especially the battery. If the battery is so heavy, your car body needs to be strong enough to hold the heavy battery. The battery is so heavy, then all the other portion need to make it lighter in order to the overall total weight may not be that heavy. We're also looking into, can we reduce the battery weight, including all the connection, wiring, packaging, protection. You see a vehicle chassis, they are really strong. Even the collision, high-speed collision, they won't broken into pieces because the material is so strong. In this case, can we develop some lightweight material, lightweight alloy to protect the battery, protect the vehicle? So that means we are not only thinking about just aluminum, and magnesium also are kind of the possibility. Magnesium is also light metal, even lighter than aluminum. So today we don't see that many aluminum vehicles, but only in competition or in some kind of the international competition, school project, we tend to use aluminum. Then we use them to develop the Formula E vehicle for competition. But magnesium is really expensive. And also you can see that aluminum and magnesium, if you study in the chemistry, you know that when you burn them, they will get on the very bright fire. So that means how to control them, make them safe will be quite a problematic issue. Magnesium, when they burn in the air, is really easy to burn, although they're really light. So that means to make them into car vehicle body, we need to be really careful about the safety. And graphite material, all these things have been used to reduce the weight for the whole vehicle design, packaging with the battery material. And then we're also looking into modular design. Modular design, that means all the vehicles are not constructed by the component. They're constructed by modular approach. So that means if the motor is broken, the whole motor module, including inverter, can be replaced directly. We don't need to rewire them. We need to repair the stator and rotor and inverter and IGBT. We don't need to do the whole thing. The whole motor inverter will be one unit. We just replace them. The charger, one unit. So that means today when you open up a vehicle, then you see that there's a lot of things inside. They all are in modular, motor modular, and then battery module, charger, no more. So that means today, all the things are modular design. If you go to repair your vehicle, fix your vehicle, they don't need to repair anything broken, just replace the whole module. So that means in theory, you can repair your vehicle within a few minutes. Because in the past, when we have our gasoline vehicle, there's so many different small and big parts. But today we don't have that. So that means that would be a really nice way we can reduce the manpower, because manpower is too expensive. Then we can reduce the all the repairing time in the component and also extend the lifetime for the vehicle. Then another technology we're looking into the end of life recycling. When vehicle near the end of life, how are we going to recycle their material, including battery and all the material? So we need to look into this kind of innovation. So that innovation must be done in the manufacturing. When you manufacture or design a new vehicle, how are we going to make sure that material will be able to recycle, reclamation, so that we can reuse them? So this kind of technology also extends to the battery. So the battery, we need to gradually move on to the battery technology that will be also recyclable. Today, we don't have such technology. When we manufacture a new battery, it's much, much cheaper than we recycle the battery to reuse them. People may think, oh, we recycle them, then we can use the original lithium cobalt. We don't need to buy them because they are so expensive. But that's not the case. If we want to recycle the important material, it's very expensive. How to filter them, how to remove them, how to clean them, how to reconfigure them into battery material is really complicated. It's really expensive. Usually 5 times to 10 times compared to a new material, a brand new component. So that means today all the battery, we don't recycle them because so the battery, for example, 1 kWh will, for example, cost you about $1,000, right? But if you try to recycle the 1 kWh battery, not $1,000, maybe more than $10,000. So nobody will do that because our technology, the battery itself is not sufficient for you to recycle. Impossible. So that's not a good thing to hear. Although we tend to work on the electric vehicle, so how to do that? We need to have some standard, international standard, a government standard, make sure the vehicle can be, or its component can be recyclable. So this picture shows you about some new material called the bio-based battery material, which you can click on this website to understand more about it. So they use this kind of new material for making the battery. They are biodegradable. So in theory, a battery made from this, at the end of life, we can landfill them. They can biodegradable. Today, if you landfill a battery, they are not biodegradable. They can be there for 10 years, 20 years. Maybe after 100 years, then many material can be degradable, but the plastic still there for another 500 years probably. So that is not something we like to hear, right? Anyway, so how we do that? We need to develop an innovation in the recycling technology. That innovation, including many other research. For instance, when the components stick together, then we need to have some special solvent to remove the material. Because when, for example, like the electrolyte, the electro separator, they all stick to each other. You can't separate them. Then they need to develop some special manner called hydrometallurgical process, which using some special solvent in order to remove the important material from the battery. So that's using solvent technique. Another technique are using high temperature to remove them. So that's called the pyrometallurgical process. So once you heat up, then the metal, including either lithium or cobalt, maybe lead, they can therefore evaporate. Then you are able to remove them, recover them. But of course, so we do have some chemical process to do the job. Of course, we do prefer direct recycling. Some techniques are able to remove this material from the battery without too much of the complicated process. So what we like to do with direct recycling. And sometimes mechanical process, we can just remove some material, like some connection wire, screw, or covering by using this method, remove some of the material. And biological, we use microbulk, which are able to use special method in order to take out this material. So this method, I'm not quite sure too much about them, but that's majorly about 5 different methods. We can use them to recycle the battery or recycle some electronic component there. But the problem is you can see that all these processes are usually quite expensive. So like these two, high temperature solvent are expensive. And then mechanical process, a lot of manpower, a lot of machine need to do that. And biodegradable system also really expensive. This research is also expensive. So that means today we don't have that many infrastructure. We don't have a system to do the job. It's mainly about a kind of the broken pieces. We don't have system method to do all this recycling. Only occasionally research or small project we're able to do that. So that means how to work with them, how to develop the concern for the hazardous material is something we need to understand. Anyway, so then today we're looking into the recycling of the vehicle for the battery. So we go through the literature survey, we found that there are a number of the good company in the worldwide, they have been working on battery recycling. Although we know battery recycling is a really complicated procedure, it's not easy, it's not making any money, it's just doing the job for recycling. Like Li-Cycle is an American company which is working on a lithium battery recycling. They can recycle a number of critical components. They have technology, like the technology we're using here. They're recycling the lithium and cobalt important material to do the job. Another global material company called Unicorn, so which are able to focus on battery recycling, recover certain material. So that is also quite important. Another is the redwood material. It's actually from Tesla. They try to recycle their own lithium-ion battery. Then in this case, once they do that, because they manufacture their own battery. So if they recycle their battery, they can put back their material into their supply chain, become more cultural supply chain development. Another big company, Battery Solution, they also are US-based company. They are really good in recycling service for their lithium-ion battery and also other battery material. IEA, International Energy Agency, they focus on recycling IEA promotion of the sustainable practice. So mainly about the recycling, and also develop a number of the policy to support other country, other agency for the recycling. In Europe, the Battery European Partnership is also a big company in Europe, BEPA. So that's a major company to develop the method for sustainability, recycling, and method. So this company is now major in Europe, have been working on not only recycling and also economic practice to support this issue. You see, recycling mainly about the government policy, about the investment. We also need a lot of donation. So that means all these things are quite difficult. We know that recycling is not making any money. It's just good for the environment. So without government support, without policy, then that will be really difficult. We also need some user able to use the recycled material. Because when you recycle them, usually firstly, they're expensive. Secondly, the material may not be so pure. You need second stage and third stage to further filter, reorganize materials can be used. The material may not be the same as the normal supplier. For instance, if you want to make the lithium battery, then your lithium usually from lithium carbonate. Then in this case, there's not a good supplier for lithium carbonate. Then the vehicle battery, they will buy in this kind of this kind of format for the lithium carbonate. But when we recycle them, your lithium may not be lithium carbonate. That may become lithium phosphate. That can become a lithium oxide. So in this case, you need to further process to change them into lithium carbonate. Or you can ask a battery manufacturer, can you not only accept lithium carbonate, can you only accept lithium oxide in your factory? So we need a lot of support from the user, from the government, from the agency, and to do that. So section 8, we like to discuss about the human-machine interface. You see, for the future vehicle, right? We're talking about future vehicle. That vehicle has to be really good for the human interface. Human interface, that means not only how a human connect to the panel, connect to the control system. We like to have different way to connect with the vehicle to control them. So the human-machine interface always become important because we don't have brainwave yet. Even brainwave is still a human interface, right? Human-machine interface. So that kind of development for EV, we make sure that that kind of human interface method should be able to connect the human to the vehicle properly. This connection need to be related to the user experience. We call it UX, user experience. So this user experience will be very important for us to develop human interface because, for instance, the keypad, what kind of keypad pattern will be good? What kind of shape? What kind of arrangement of 1, 2, 3, 4, 5, 6, 7, and 0? What kind of arrangement? You need at which location, left, right, center? Many things we need to look into. And then how the interfacing look like with physical interfacing or through the website, through the apps, through the Bluetooth, through many other connections. So that's how we need to develop proper HMI. So HMI is not only about direct contact, can be any interfacing. So that including how make sure that the functionality will be good, the usability will be good, and that also need to look into the human emotion and also the conception. For the usability, they need to have how easy, how intrusive, need able to do to complete all these tasks. Not only simple human connection, but also need to provide, for example, like touchscreen will be something being used quite often. And also in the Tesla dashboard, they now they don't have dashboard, yeah, in Tesla vehicle, because even the whole dashboard will be costly. They only now put a screen there. You can have touchscreen to control everything. That will be much cheaper. Lower cost. A touch screen like this only costs $100. Even do a dashboard, probably will be a few $1,000s. So that's why Tesla, like many other vehicles, they're doing some design, make sure that it's not costly, easy to use, better human interface. Yeah, so that's because we have been get used to the touch screen anyway. No point for us to develop a mechanical dashboard to control the vehicle. And also accessibility. So make sure that we can design something for the driver that easier for them to control. For example, like voice control, then there's something have been used. So the design philosophy for the HMI, including what? Including firstly, importantly, will be emotional design. So driver need to use a vehicle highly related to the mood, to the emotion. So that means we need to create a condition, even though the lighting condition and the temperature condition, that will be much easier for them to adapt. So that means the creating the delight and trust between the driver and the vehicle will be important. Information architecture. There's so many information there. Although all the information will be necessary for driving a car, but we need to organize all the content properly in logical manner, easier manner, so that also group them properly. So this section will group into here, easier for you to get control. Just like today when we're using folder, we have different folder, right, to control different kind of the controllability. Interaction design. So it means how we control them, what kind of interaction we need them, how to use the button to do it, voice control or gesture control, maybe have some haptic control in our steering wheel. So because when we're driving our finger on the steering wheel, we don't like to touch it so far away. All the control on the steering wheel called the haptic control, that will be much easier to do the job, to control, much safer. Of course, the development of autonomous vehicle can make the driver don't need to do anything, or vehicle will be adapt to certain pattern of the driver requirement. Then that is another way for the HMI. HMI don't need to be physical connection. They can already program them before that. It's also a kind of the HMI, like the autonomous vehicle. We program the vehicle, have self-driving capability, that pattern according to your human thought. Connected vehicle, of course. Connected vehicle, they've been mentioned in the other section. So we need to have a seamless integration with the phone. So nowadays we have phone, we can use the phone to connect to the vehicle. You can, for instance, my vehicle as well. Today is too strong sunlight. If I go to my vehicle at 4, it will be too hot. Then before I go in my office, I press a button from my phone, ask the vehicle to turn on the AC first. The vehicle will be cool. So that's something has been happening in most of vehicles. So that means connected vehicle, connected app already here, but just depend on the capability. Sometimes they're doing really good job. Sometimes they only have some minor facility. Say augmented reality, we mentioned that, right, just now. Augmented reality, that means you like to project your control and navigation on the windscreen. Windscreen will be like in your windscreen here, then only can see through. But if you're able to project information there, like in the movie, right? In the movie, you can see they try to use AR, augmented reality, to project anything on the table, on the wall. They can do this control. But it's already happened. So they try to do them using the heads-up display HUD to navigate them in the windshield on the vehicle, in the windscreen. So this data projected on the front of your eye, right? You can be able to do anything quickly. You don't need to navigate it, move your head to the screen, move your head to the front, and then you need to look back. It's very inconvenient. You don't want your head too far away, look to the front. So in this case, they need to use augmented reality. So what if this will be like that? You see, this is a picture. When you're driving, the driver only want to focus on the in front of you. So that means they can use AR to project everything on the windscreen here, instead of looking at the computer screen here. So in this case, this kind of projection system, they can use laser, LED, LCD, project the image on the windscreen. Then this case will be semi-transparent. You can see the front, see the traffic in front of you. You can also see the control in here. So that's not really a story now. And say BMW, AR, HUD already doing that. So you can check their website how they do that. Of course, their capability is not as good as the movie yet. In the movie, we always see that, but it's not that intelligent, right? And also, they're doing something about that. Sensor integration. Then the AR nowadays, they can integrate with GPS, camera, LiDAR to do the job. You see, when you use GPS, you still need to look into your phone, maybe your computer screen on the vehicle. But now they're using AR, they can project the GPS map on your windscreen, on the so-called windshield here. You can able to navigate your road by looking in the front only. Not only this one, they can have real-time processing. So that means the AI can able to process all the road speed, condition, obstacle, and even the pedestrian nearby, they can give you a much faster response. And interfacing. So they are able to provide you a fresh layer of intrusive interaction. So the driver can able to use the car function, in-car function, and maybe your gesture, in-car function, voice control to do that. So sometimes this projection can project to a way that can meeting the road condition. Not just projecting, use some other control button. They can project to say this point is a human, this point is a kind of the dirt garbage. They can tell you exactly on the screen what happened. They have pointer to tell you what happened. So rather than just display only. So like in here, the navigation, I think this normal thing happened. So the road condition here, they tell you the navigation. But now then, their projection able to project on your windscreen what happened. Say here will be have a hole, here will be a human. You need to be careful. So they will project what happened. The information, the alert system can project on your windscreen rather than just give you simple, beautiful picture. So they can able to put them together, right? They're not separate. When you project the alert system on your windscreen using AR, they are actually overlap with the front road condition. So that's important thing. So it can involve projecting digital link marker, project on here. So in here, because it's dark, maybe raining day, you can't see the marker. Then when you drive, it will be very scary. But however, if they project the link line on the windscreen, then you can follow much easier. So that will be quite important. So the real-time projection of the AR for the navigation on the windscreen will be something we need to look into. Say in this map, real-time projection for information on the road overlapping with the outside, then that's so important. So that is promote the safety, highlight the hazard in case any sudden braking or cycling, and hazard on the road, they can also tell you exactly what happened. So that's what we're doing for the future vehicle. Some feature already here, but now we need to work on more for the future vehicle, make sure that all these things could happen. So the AR now getting important. For instance, when you drive a vehicle, they will project you the route you're going to drive. When you see this, they try to coordinate these two to be the same. So make sure your drive will be more safety, much more information. They can project you about the way you drive, they project the link here, the link mark here. How to do that? For instance, when we're driving a Tesla, when you want to park, the Tesla tell you that's the parking space, that's the vehicle nearby. They project directly on the screen, but not on the windscreen, but on the project on the computer screen to tell you the exact boundary for your parking and the vehicle nearby. Can help you to adjust much better. Before we only can use the reflected mirror, then that's not accurate at all. But now then all the marking, the boundary can already projected on your windscreen or computer. In this case, this AR technology can help you do much better. So if you experience any vehicle, if you're driving any autonomous vehicle today, you should be able to see that anybody are driving an EV, or you have been using an EV or sitting on EV, then you can see all this AR technology partially on EV, especially like this driving route, the marking, yeah, all this projection, they already here. But in here, the AR technology, they try to do one step further rather than project it on the computer screen, be projected on the windscreen. Project on the windscreen, then we are able to see much better, can coordinate the road condition much better from the driver assistance system. So that's what's happening for all the AR technology. Section 9, we try to talk about the centralized and decentralized control. So all this topic today, we're talking about future vehicle, how the future vehicle shall look like. Another area about the centralized and decentralized control will be, you see, we have been discussing about the EV and autonomous vehicle design. What kind of control method we should do? Do you think everything will be centralized to a central computer, VCU, or some of the control we can able to perform in the component side? Just like the human being here, we've been using a lot in the centralized control. All the control, if you want to do any writing, exam, driving vehicle, everything, we sense the thing happening from an eye, from an ear, from a finger, all go to the brain. The brain make the decision to tell what next, how you control the vehicle. So that more look like a centralized control, right? So that means centralized control has been used in many systems, human, animal, and many computer systems or building management system, BMS, battery management system. They've been using certain amount of the centralized control. Then for the EV point of view, shall we use centralized control or decentralized? Decentralized, anybody can tell me what's the meaning of decentralized?
If like different farm has their own owner,
Mm.
you can control the view according to the view feedback. Not you don't need to deliver the message to the receiver.
That's why in a company, you got CEO to control everything, centralized control. But CEO cannot do everything. Some minor thing you need to dedicate it to the manager, branch manager, or supervisor to make decision. So that means we can't have a system only a centralized control unless the centralized decision making are so powerful. But it can't be. Everything need to communicate. The time it take too long. May not making a rapid decision. So even the company CEO, they're using micromanagement. They want to look after everything, but it doesn't work. So some of the control and power decision need to be made by more local or branch or division manager to do the job. Or sometimes we need to use hybrid system to combine that. The same kind of concept is now being discussed in the EV development or autonomous vehicle. Then in a normal conventional vehicle, of course, driver make all the decision. And then, but now for autonomous vehicle, many of decisions either to use centralized and also decentralized intelligence should be there. So the choice is not a single decision. That's the trade-off. We need to mix them, hybrid solution. Some decision we need to make centralized, some decision we need to make decentralized. Which one will be more, will be depend on your vehicle design or what kind of vehicle and also the user behavior. So I think both systems exist in present and future EV design anyway. But say which amount higher maybe 50 to 50, or maybe 90% centralized, 10% decentralized, depending on your vehicle design. So that means our vehicle design should able to provide centralized, decentralized, or hybrid, a combination. So that means centralized, decentralized have been seen in many different kind of design in a factory, in a corporation, right? In your household, maybe your parent make the whole decision. Sometimes they provide some decision making to the kid, or maybe to the domestic helper. They can make certain decision. So that's always happening. So let's look at some example, right? The centralized intelligence method is at the moment still the current trend. So like the NVIDIA Drive and Tesla, the Joy and Quantum, they've been making this kind of the centralized control for the vehicle. The good thing will be they can have AI control because AI now is really powerful. They can able to make the processing autonomy much better. Even though the infotainment, entertainment, they can able to do really good. And the latency, the delay between the system is not anything. So they can very easily to get the centralized control. They control with high speed and manner. And in this, because they are using some special communication method, the data transmission method, the data can transmit from the component side, from the vehicle location back to the central computer VCU really rapidly. They can make decisions really good. So they can lower all the wiring capacity. Of course, in this case, then in case there's any failure, for example, like the central computer crash or critical or whatever, it may affect the whole vehicle system. The vehicle can't do anything because they are using centralized control. Then central computer have any issue, the whole vehicle become not working. And then sometimes real-time processing have the bottleneck problem. Yeah. And in case, for example, like urgent braking, emergency braking, if the signal transfer to central computer and make the braking, sometimes can be quite slow. Just like human being, when you usually our hand movement are according to the brain decision. But in case we touch something really hot, we don't need the brain decision. Or we'll just retract our hand. Build a local intelligence to do the job. Local decision need to make. If you pass through the brain to withdraw the hand, it may take maybe 1 to 2 seconds. It's too slow. The finger already burned. So that's why some kind of local decision, decentralized decision need to make. So you can see that the real-time processing through the central computer do have a bottleneck problem. We can't make really 100% really good, really fast safety decision really well. Important thing like the braking. Braking is something so important. We make the decision really quickly. Braking can happen anytime. Suddenly is that obstacle. Suddenly a kid come out from the come out in front of your vehicle. You need to stop the vehicle, right? So decentralized also have been used in many other systems. For example, like in Tesla, the early development for Tesla, Meridian shown architecture, AI chip, in the sense that they are using this kind of the decentralized. So decentralized, that means we have some kind of the decision will make locally. So avoid processing time, especially for some computer system, not that intelligent, not that high speed, they do need are not the decentralized control method. Decentralized because the intelligence putting a big portion in the local. Even though one location is broken, one location not working, we still have other location to do the job. We don't need the central decision. And also scalable. Many of the model approach, for example, like the motor, all the motor are in model approach. This motor is broken, then we can just replace them. We don't need to replace the whole motor system. And for efficiency point of view, we are able to handle localized task and localized risk. So that's something we see the advantage. But however, whenever we decentralize, all the data synchronization, data transfer need to have really good coordinate, because each of the local decision can be quite deviant from other. How to coordinate them is kind of the problem. And then in the future, if we want to any further upgrade, then we also upgrade the central computer, then may not be that easy. And then that's why everything will be divided in the zone control. Of course, today we do prefer a hybrid solution. No matter how good your chips, AI chip like, there will still a lot of the delay anyway. We do looking for a much higher speed of the control. So in this case, hybrid solution is something we are looking into. So that means we need to deliver some central intelligence to some major decision making. For example, like the routing, planning, V2X communication. Then decentralized, we call the Edge AI. We are able to allow them for more routine thing or long that critical decision. Or sometimes some really critical decision we need to make so rapidly. Some decisions related to safety, without any thinking, you think that much unsafe, you can make decision really quickly. For example, like when a vehicle, you sense a human in front of you, within a few meters, you need to make quick decision. You need to stop your vehicle anyway. So you don't need to go through the central computer to do that. So decentralized Edge AI need to do that. So they have a chips in here in the camera. When camera see anything, they don't need to go through the central computer. They can make decision. So this benefit will be we can able to balance the computing power between the central and decentralized, and also the coordination. They can also enable the safety. So all these systems already have some international standard there, like the ISO 26262, right? They also have this kind of the safety feature into here. But all these things have been doing. We still try to implement all this in the future vehicle. Here we're discussing them, but the actual implementation of all of this is still really slow. So now then we're waiting for much better computer chips to do the job. So the key technology, key thing to affecting all the centralized and decentralized capability is the Edge AI chips. So we do have now looking for some better AI chip to do the job. So of course, the Hero has been making some low power AI accelerator for the Tesla camera to do the job. And also we are TSN, the time sensitive network. So you see, when we're doing the decentralized, there's a lot of the data transfer. So we need to prioritize this data transfer, which decision need to make better, faster. For instance, braking signal against the infotainment signal. When you press the button, want to change the song, it's less important than braking anyway. So, and sometimes when your vehicle approach the corner, you need to make decision, turn left or right. That would far more urgent than your entertainment. So that is the decision, the time-sensitive network control system to make neuromorphic computing. So we try to make the future chip more look like the human brain and inspire decision. So they will look at this processing capability so that they are able to connect with the sensor data with really low latency to do the job. So now we are looking into this kind of the neuromorphic computer. So, and then next thinking what to be decentralized. Of course, something really important safety issue, like what I mentioned, important braking. And when we approach to a diverted road, which way to go, we need to make quick decision. And also some kind of the sensor, like the LiDAR, some camera, we need to reprocess them. We don't need to process them to the VCU. We need to process data first inside the LiDAR. LiDAR today have a little bit of chip inside. They can process the data before they send all the data back into the VCU. So after they process them, you can therefore reduce the processing, the central computer, reducing the data management. Legacy integration. So many of vehicles, they are working on decentralized. So, and also the aftermarket automation. Some vehicles, when they buy them, they don't have that many automation, but the driver, the user may like to add on many new features to them. When they want to add a new feature, then that means the best way to do will be decentralized. Yeah, for example, they're adding a new LiDAR. Before the vehicle only had one LiDAR in the front, but now they're adding one more LiDAR at the back. In this case, that will be decentralized control. They can easily to add on one more LiDAR or many other sensors to do the job. So the conclusion, you can see that here, future EV are likely to adapt to mainly about hybrid model. I don't think any vehicle only using a single model good. They need a combination of different features, including hybrid solution. Centralized, decentralized must be parallelly to be there, depending on which one will be first, right? More. And then in this case, we can able to resolve the problem for some time critical task and energy saving critical tasks, decision critical tasks to be do the job. So to conclude what we have learned, right? So this chapter mainly looking into some kind of future vehicle. Many of the topics we discussed here have been doing a portion, but not everything. So that means I think in the future, the vehicle will more look like an intelligent system. I always think about the future vehicle more look like a robot. Because I can see that unless a human-like robot, but robot can be any shape. So don't need to be a human look. So a robot and vehicle is the same anyway. So that means today I'm researching in EV. I think tomorrow, robotic control, robotic system will be getting more important. Then my research will move on to robotics, right? Because all the things I do for the battery, charging, motor, linear motor, actuation, they all are important components for robot, like the sensor, wireless charger, they are all this. Then the future vehicle will more look like a smart office. Today, we have smart office in our house, but I think a vehicle itself can be its own smart office. We can able to control many things inside our vehicle. We can, because V2G, V2X, the vehicle can connect to many other connections. So that means our vehicle will look like a smart office anyway. Then the vehicle also has many functions. In the past, our vehicle may have a CD, may have a tape recorder, but nowadays our vehicle can connect to many entertainment or infotainment, connect to internet, pay anything on the vehicle. So they can also control various things, connect with other vehicles. So that means besides entertainment and control, we also looking at the basic EV component. We also need to have higher function, like in the braking. We all know what braking is, but what's the future intelligence in the braking? Then we need to, for instance, some anti-lock braking system, in the 100% electric braking, not using hydraulic. Hydraulic is not environmental friendly, too slow in response. When we develop higher force, higher torque, and higher power motor, we can able to replace all the hydraulic system by all electric braking. And also suspension, right? Suspension is a major thing we need to develop in the near future. As I mentioned to you, suspension at the moment are only using hydraulic or electrohydraulic. The response time is too slow. We don't like hydraulic liquid inside the vehicle because we are electric vehicle, not hydraulic vehicle. So the hydraulic system will be replaced by the active suspension. And the next thing will be motor. The motor charging system. How we charge the vehicle besides conductive charging, Of course, next few years, we're going to see a lot of the wireless power charging. A coil will be put at the bottom of vehicle for the charging. Many of the car park area, road area will have many coil to support the charging. But of course, that need a lot of investment anyway. But that's a really good way we can make our city become really smart. This coil not only to charge our vehicle, but that coil can charge our phone, can charge the wheelchair, can charge our computer. So in this case, we're able to connect the power to our computer. We don't need to worry about our computer. I don't like this thing. Yeah, everything you need to connect with this kind of adapter. Then you can see that in the future, if we use wireless power transfer for vehicle, that charging can also charge our computer. In this platform, this kind of laptop, we have coil here. You can charge our phone, can charge our computer, can charge our watch, right? Then we don't need to worry about the power. At the moment, we can't use the EV and mobile properly because of the charging. EV, we always think about the charge. Robot, we can use it only for half an hour, 1 hour, you go back to charge. And so that means there's a lot of good way to do that. So that means in the future, the charger is something we're looking into to charge a vehicle. We try to charge the EV everywhere, not only in the charging station. Once we use wireless power transfer, the charging can be actually in many other locations. So we're also looking into more automation, right? How to develop vehicle into more automation. At the moment, we got level 1 to level 5 for the autonomous vehicle. So up to level 5 is already become quite mature. So next thing we do will be make sure the vehicle will be more level 5. But to do this one, we need legislation. How to make sure the vehicle responsibility in case anything happen, who will be the one to take care of the responsibility? Is the driver, manufacturer, the government, or the passenger? Not quite sure yet. There's a lot of the argument in terms of the responsibility, insurance to do that. At the moment, something not fair will be electric vehicle insurance usually higher than gasoline car insurance. Yeah, I think nearly double. But that shouldn't happen because in electric vehicle accidents are much, much less than gasoline car. Electric vehicle have not the protection out of sensor, which is much better than gasoline car. So their insurance should be much lower. But today we have much higher insurance, which I don't understand why. So that needs to be changed, right? So that means more automation in the future, the whole vehicle system could be more autonomous. And then we are able to implement more self-awareness. The vehicle itself not only automation. Automation means automatically make decision, but that decision need to be careful. Although many decisions have been made according to human interface, according to human input. Human the input from A to B, go to A to B, and take care of traffic in between. But we do need to have self-awareness for the vehicle. Like that will go to level 6 and level 7. Have more self-awareness for the vehicle. They can make certain decisions without human interface. I think we have been doing it. I mean, like the vehicle, they can traffic light can stop. When they see a pedestrian crossing, they will wait. When they see a big lorry next to it, they will try to avoid them. And they are using some self-awareness. But that self-awareness for electric vehicle, for autonomous vehicle, need to increase further its capability. And then for user interface as well, today, interface of vehicle, we use a lot of the control button or phone control, right? Tomorrow, we are looking into more different interface. The interface can be HMI, human and machine interface. That HMI not only for physical touch, can be for wireless, or can be for predetermined HMI. And then we can also interface with other body, other infrastructure, like the V2X vehicle to everything, right? So a lot of interface we're looking into. Interfacing not only physical wiring connection, can be through other means, like the Bluetooth or Wi-Fi or 5G, or maybe future 6G or so. But however, the first thing we solve the vehicle, we have so many things like to do, right? But we need to make priority. Which one we should be more important? That's the thing we look into. Firstly, I think more importantly, I have 3 points here. Firstly, EV is not yet popular. In the United States, we only 2%. Other countries maybe 10%. Some countries maybe already 50%, right? we are still doing too slow. So first thing to do would be make the EV become more popular, more education to tell everyone we have to use EV because of the global environment. We need to save more energy. EV efficiency at least will be 3 times to 5 times compared to gasoline car. So why not to use EV? We can reduce the emission. Second thing will be the cost. At the moment, EV is still expensive. At least compared to the same kind of performance vehicle, double the price. You buy a Tesla, 50,000. I think you buy a Corolla, 25,000. Probably it's a similar performance. Of course, EV sometimes have better performance, but average performance, they are quite similar. So that means usually double the price, which we don't quite like that. So how to reduce the cost? We're not quite sure yet. Depend on car manufacturer, carbon interfacing, and also incentive, tax, others. That's the thing we can do. So that's the first thing we need to solve in the near future. Education, educate your user to use electric vehicle. At the moment, we don't have any proper teaching, lecture, or promotion to promote the EV yet. We don't have any advertising and education in the school to tell us why we need to use EV. Only me. I'm the only one educate everyone to use the EV. So that means we need to educate user, your parent, your friend, why we need to use EV. Is it safer, cheaper, good for the environment? We need to train more engineer. Once we have more EV, we need more educator, engineer, technician to repair, design for the EV. You can see that today we only 2%, but after 10 years, maybe have 70%. Then how many technicians or EV worker we have for the United States? About 1 million. That 1 million people, we need to change them all into electrical engineer so that they know how to fix an EV, repair an EV. At the moment, they don't know, they not even know Ohm's law. So how can they fix an EV? So that means we need to retrain them, retraining. After 20 years, no more mechanical car disappear. They will lose their job. So we need to have a retrain. All our course need to have an EV Bachelor of Engineering in electric vehicle. So that's the thing we need to do, right? So that means in the near future, we more will be like that. You see that robot and EV are quite similar, as I mentioned before. It's just how the outlook look like. So firstly, we need to make sure the man-made awareness. So the EV or robot, we need to make sure that they need to understand the safety, vehicle control, and better communication, V2X. That at the moment, what we think about the man-made awareness for the EV and the robot. And the hardware as well, hardware itself also have certain intelligence there. For the future EV, and we're talking about future. You see this topic, we're not talking about today, we're talking about future. Future EV, the hardware also have its own awareness, including you can self-recovery, self-maintenance. Maintenance. Before today, our maintenance go to shops, change the oil, change the water, lubrication. But tomorrow, the EV need to have self-maintenance, self-generation. They can produce they copy their vehicle, and self-regeneration. They can repair by themselves. If the one motor is broken, they can repair by themselves. So that's called self-regeneration. That's how we see the EV and the future robot show look like. Future robot, the good future robot, just like the movie Terminator or whatever, they can have self-generation, self-regeneration, self-recovery, self-maintenance. They may not have self-generation, but self-regeneration should be something can do. Because self-generation, they need additional material. They need to sort out how the supply chain look like. And also ultimate awareness, not only these two, but also relate to the cultural and societal, including emotional and social behavior, self-actualization, self-transcendence. So all these things is a future awareness we needed for the future vehicle. The future requirement for vehicle and robot, I think, will be the same. Today, I'm doing research in EV, but I think robot is the same. We just change the outlook from the vehicle into the robot, that's all. So next EV in the near future, we need to do, right? Near future, to do with further improvement in energy storage. We need to improve the energy storage, battery, hydrogen, ammonia, Safety. We are using battery, but safety need to be do it properly. We also need to look into how the battery recycling. So that's also future things, but near future thing, we need to look into this field. Rather than something intelligent robotic car, we're not looking into that. There's slightly more future. But the near future, we need to look into that. And then when we design a new vehicle, we need to look into the new configuration, new design, new outlook, new arrangement, new interior, new feature, new application, and new function. So at the moment, our vehicle is too classical, too conventional. You only just modify from the gasoline car. But today we know that EV can do more. So that means anything related to EV design configuration need to be redo. So we need to gradually move forward to adapt all this new feature and technology. So the vehicle, I think we do have a lot of future vehicle project, some idea. What my research idea in the near future could be including intelligent or hybrid BMS, EMS, like my student Ali is doing that. And we also look into energy saving, how to provide better saving for autonomous vehicle, like the suspension system, decentralized EV design, we need to look into that. Also battery development, higher density, that related to material. We need to develop higher battery system like the lithium sulfur, lithium oxygen, and new motor technology. We need to design some new motor, higher power density for EV, and also super high voltage. At the moment, we're using 800 volt. So we use 2000 volt to have high voltage because we demand for high power. So demand for high power, not only for better efficiency, but we need to go for high voltage. And the multiple motor design. At the moment, we are too conventional. We have four-wheel, we think about four motor, but that's not restricted. When we use EV motor, we can have multiple motor. You can have 5 motor, 6 motor, 7 motor, 10 motor. So we think about the design. And then we also need to look into super high power charging. At the moment, charging is too slow. We think about how we charge better. Can we have a high power charging? I told you, high power charging is inconvenient because we don't have sufficient source. We need to think about how to do the charging in terms of 3D, any location, not only stationary in charging station, but when the vehicle moving, we're able to charge it. So that's what we like to do. So finally, my quote would be the future of mobility electric, intelligent and seamlessly connected and transform the vehicle from mere machine into responsive extension of our life. The future vehicle are doing that. Will be extension, responsive extension to our life, not only a EV, more than that. All right, more look like a future robot, future servant, future intelligent robotic servant to us. Anyway, that's all for the future vehicle. Hope you like it. You can look in the future, how our future vehicle look like. In the future, if you like to do our research in electric vehicle, future electric vehicle, future robot, you can come to me. Anyway, that's it for today. All the lecture will be there. My YouTube channel will be there. You can review my lecture. So next week, we continue with some other new things. Okay, so we're still here next week. We still have 2 more lecture. After 2 more lecture, we have a final exam. Will be in the Friday after this week. All right. Okay, that's all. Any questions? No? Okay. So happy to see you. See you next time. Bye-bye.